So far, we have looked extensively into the use of diodes in power electronics and N-channel MOSFETs. Furthermore, we have quickly met the NPN bipolar junction transistor when we looked at linear regulators. That does not at all mean that all linear regulators contain bipolar junction transistors. This was just an example. Most of the modern linear regulators are built with MOSFETs. In fact, bipolar junction transistors are rather rarely used in modern power electronics, and their usage is reserved to circuits operating in the microwave range, as they are still the fastest devices that we can get to operate electronics. In between a bipolar junction transistor and a MOSFET, we have the so-called IGBTs. IGBT stands for insulated gate bipolar transistor. The insulated gate is a hint to the similarity to MOSFETs, and the bipolar transistor is a hint to the similarity of bipolar junction transistors. In fact, their drive is very similar to the MOSFET, and you can actually use MOSFET gate drivers to drive IGBTs. The power part of the transistor is very similar to the behavior of a bipolar junction transistor. It has a gate, it has a collector, and it has an emitter, where the gate is inherited from the MOSFET's gate drive behavior, and the collector and the emitter is inherited from the BJT. In modern practical applications, IGBTs show up at voltages where MOSFETs cannot withstand the blocking anymore. And practically that range starts at about 1200 volts, and the next category of IGBTs are 1500 volts. Above that voltage range, and also far into the kiloamps range, we have triacs and thyristors. Thyristors have a similar forward characteristic like the MOSFETs and IGBTs, but their characteristics can be shifted along the x-axis. In the reverse range, they behave very similar to diodes. So compared to MOSFETs, they can actually also block negative voltages. Triacs have a symmetrical operation range with the symmetry to the origin, and both their forward and their reverse characteristics can be controlled by a gate trigger. The practical use of those devices is in power drives and in applications like electrical trains, like S-trains, and other applications in the 100 kilowatt range and above. This is also where we are actually getting over from power electronics into power systems.